All right, what's going on, guys? Happy Thursday. It is asynchronous classwork day, so you're going to start this for classwork. Might have to finish for homework, but I'm just going to do it all with you here right now. So hopefully you understand the purpose of this, which again, we're solving systems. Yes, we have systems over here. And check out, I got my friends here. I got my friend Jeanette. There's my friend Jeanette. She goes to Fremont High, free with 2 E's. So it's not the Fremont High School in the Bay Area, right? In East Bay, yeah, Southern East Bay. Anyways, not that, Fremont. Anyway. We're talking about here. All right, this is our unit, solving systems. Okay, system. Now my solution is there. It's still the one that's 2-1 for the solution. Anyways, we don't really oftentimes have a graph, so we can't find the common intersection of 2 lines. So we got to solve for it algebraically, and that's what we're going to start with on number 1. Okay. The goal of this is solving systems using elimination. This is usually the lesson that I use to introduce elimination to people. That's right, introduce elimination people. And yeah, you got introduced to it yesterday. So why don't we just do it and see if it made sense here. All right, so you've already done substitution method. You haven't done this thing called equal values method. You don't really need to worry about it. It's kind of like substitution. And here we're going to learn a better way for something like this, which is elimination. Yes, that's right here. So when they're in this form, one thing to point out here too, I've mentioned this a few times, this is the standard form right here. I can't even really see it, the standard form. When both your equations are written in standard form, right? Standard form is ax plus by equal to c, or our x term and y terms are switched down here. But when they're written like that, it's actually, elimination is the easiest method. Simple as like that, right? Because I just got to add these 2 equations together. Then I got then I got y eliminated. I can figure out what x is. We're good to go. So all right, sorry, we're back here. I just was checking something real quick. So Jeanette's actually solving this one. You're doing 455. Let's do that one together. It says she's trying to find the common point of intersection. These are lines, right? X and Y, no variable, no exponents. And she's trying to find the common point of intersection. So they're written in the form ax plus by equals c. Elimination is going to be good, but she's actually decided to use substitution. So hey, just to show you about how messy substitution is here, and to show you that you could use substitution to solve this, let's actually use substitution here. Her plan is to solve the first equation for y, and then to substitute the result into the second equation. Use Jeanette's idea to solve the system. Okay, so let's bring this down here. So the idea is that she wants to solve the first equation for y. So that's something we haven't really done too much this year, is solving variables here. How would I solve for y in this one here? They wants to isolate y, right? Which means to solve the first equation for y, she wants to isolate y. That means I want to get y by myself on this side of the equal sign here, okay? So I have here y. I got 3 of them. I got 3 y's, and I'm adding 2 more x's on the left side of the equal sign here. So I want to solve for y. So this is a quick reminder on, because I'm using this to substitute later. Anyways, quick reminder on how to solve for something here. So remember, what I say to solve for a variable, I say start simplifying away from that variable. My variable is here, okay? So I'm not going to deal with the 3 first. I'm going to deal with getting rid of this 2x first as I try to isolate that variable here. So what I'm going to do to both sides first is I'm going to take away the 2x from the left side. I take away 2x from my left side. That means I'm going to take away 2x from my right side, and that's going to keep my equation balanced. So I'll take away 2x over here, and then my equation's simplified so that I'm isolating what y is here. Because now I just have y left on that side, 3 y's here, and that's equal to negative 2x minus 2, based on the algebra, the way this original statement was set up. So now I'm going to divide both sides by 3. Divide by 3 here, divide by 3 here. And y is isolated, but y equals, we got a nasty fraction here. It equals negative 2 over 3x minus 2 over 3. Ooh, messy, okay? So she wanted to do these substitution methods. So her idea was, I'll take equation 1, right? This is equation 1. Just to show you what she's doing here. You might be kind of overwhelmed by this question here, but she's taking equation 1, she solves for it, she gets y equal to this, right, this here. She wants to substitute that into equation 2, equation number 2, to see if she can solve it using substitution, okay? So she's taking equation 2, which I'll bring down here, negative 3, and instead of writing y, I'm going to take this thing right here, what y is equal to, right, which I solved for previously. So hopefully you follow my logic there. And instead of doing negative 3y, I'm going to do negative 3 times by what y is equal to, which is negative 2 over 3, x minus 2 over 3, close parentheses, and this is negative 3y plus 5x equal to 16. And I can use this. It's going to get messy. I don't have much space down here. I'll use this to solve for substitution, but elimination was much easier. Anyways, like the whole purpose of this first question to be like substitution sometimes isn't the best thing. That's why you want to do the thing we talked about yesterday, elimination. So if you didn't get it yesterday, hopefully you'll get it later in today's lesson here. All right, negative 3 distributes into the parentheses. Remember, this whole thing represents y, right? Represents y up here. Negative 3 times negative 2/3. Well, that's a little tricky. You got to get back to multiplying fractions. You might have forgotten that. Negative 3 times negative 2 is negative 6. Remember, numerators multiply numerators, denominators. This would be negative 3 over 1. Denominators multiply denominators. So negative 3 times negative 2 is negative 6, and that's over 3. So negative 6 over 3 is negative 2x. Negative 2x's here. Negative 3 times negative 2 over 3 is, again, negative 6 over 3, and that's negative 2. Oh, actually, wait. Two negatives make a positive. So man, I'm making mistakes here. Look, there's a negative here. So this is going to end up just being positive 2x, and then plus 2, and then I got my 5x's here that I originally had in equation number 2, and that's equal to 16. Combine like terms, 7x, and then I subtract this 2 from both sides, right? I'll combine like terms and subtract the 2 out at the same time. And I got 7x equal 14, so that means x equals 2. And I'm a math teacher, I can do that very quickly, but my guess is that took you a little bit longer than me right there. So x equals 2, and I can go back to my original equation right here to figure out what y is. Equation number 1 was 3y plus 2. Instead of that, I'm going to put in 2, right? I'm going to put in, I could solve for x. I'm hoping x equals 2 in the other equation. And let's see if we can get a true statement here, or actually want to solve for y here in this equation here. 2x equal to negative 2. So then I get 3y plus 4 equals negative 2. Subtract both sides by 4, because again, I'm simplifying away from the y. And I get 3y equal to negative 6. So y equals negative 2. So my solution to this, solution to the system, I did all that work to find the common intersection, is going to be 2, negative 2. Okay, usually this is kind of a tricky problem in class, right? So I kind of did it fast. Rewind it, watch it again, right? Take notes on what I'm doing here, the kind of thing. But this first problem, the purpose of this first problem is Jeanette has only learned substitution so far. So in this thing, she does the right thing. Like when I did the right thing, I'm trying to do substitution. I isolated variable. She's thinking the right thing here. I'm giving her some credit. She's thinking about isolate y and then plug what you know about y, which is this right into here, into the other equation, and then solve here. And if she doesn't make any mistakes, she gets the solution. But did you make any mistakes on that? Did you not know things to do? Yeah, right? Substitution, not a great method. Not a great method when you have things written in this standard form, okay? So just keep an eye out for that. When I have my x's and y's on one side of the equation, elimination, right? And that goes for both equations, both of them, right? This is an ax plus by equals c, or by plus ax equals c. Okay, x's and y's on one side of the equation, it's probably in standard form. If they're both in it, then substitution is not great because you don't have any variable isolated already, right? If we had the equations written in slope-intercept form, right, y equals mx plus b form, y is already isolated, you can plug that right in and use substitution. Anyways, I digress. Today, we're going to review and you're going to do elimination, and hopefully that's easier for you here. So let's get into it here. 456, your class will now discuss a new method called the elimination method. Have you heard the elimination method yet? Well, I'm hoping you did the Desmos yesterday. I'm hoping you paid attention. It seemed like things went well in that Desmos. That was pretty neat, right? We can modify equations, and they're going to still find equivalent equations. They're still going to go through the common solution of the system, or the lines will stay the same. So basically, we want to figure out how we can change the lines, add them together, eliminate a variable. This is actually going to be easier today here as we do some simple elimination problems, okay? To find the solutions of Jeanette's problem without the complications of fractions from the previous problems. Really, that was messy here with fractions. All right, your class discussion is outlined below. So there are these things that I'm doing it normal here. We can't do this here because how can you get little pieces of tiles to you guys? I'd have to mail them to you guys. So this is called an equation map. You probably dealt with tiles in middle school. So lucky you, distance learning, you don't have any tiles this year. Okay, so don't worry about this. You're not building this out. You're not doing this. Okay, you're not doing this. But the idea of this is that we got 3 y's and 2x's on one side of equals. This double bar here means equals, and that equals -2. It said build that out. Okay, build that out. I have this equation here, okay? So what they say down here is that I still have this equation, 3y plus 2x, right? 3y plus 2x equals -2. The idea of elimination is if we have an equation and we say add something, right? It says add 16. So 16 is just an example, a random thing here. A legal move when you have an equation is if I add one thing to one side, right? So if I add 16 to one side, I'm going to have to add what's the other side to keep the equation balanced. I'm going to have to add 16 again, okay? So for those of you taking geometry this year, that's called the addition property of equality. If I have an equation, if two things are equal to one another, if I add equal things to those things, they're going to remain the same, okay? So this isn't elimination here. It's just to remind you of that here. If I add 16 to one side and 16 to the other, I'm going to know that this statement is going to be true, right? Because I added 16 to both sides, right? 16 to both sides. That would be a true equation if that was my equation at the beginning. My given equation is true because it's given to me. Adding 16 to both sides, it's still going to be true, okay? So you don't have to do this. You don't have to answer part B at all or anything like that, right? You don't have to do that. I'm just kind of talking about it here. So the logic of this is here, right? We have an equation 1, okay? Equation number 1 from the preceding problem, which was this, 3y plus 2x is equal to -2, right? 3y plus 2x is equal to -2. That was equation number 2. We had a second equation, right? -3y plus 5x, and it was what? It was equal to 16, right? These two things equal each other based on the premise of this problem, right? -3y plus 5x, it's given to us, right? Because that's the line that this is here. And a line is showing all the true solutions of this statement, x and y, and we've got some parameters here, -3 and 5, that leads to 16. This is just a line, and we know it's true because all those points in the line are true solutions. So anyways, -3y plus 5x, well, that is just 16. So this statement here is no different than 16 equals 16 because -3y plus 5x it equals 16. So the point of this problem is letting us know that here we can basically take equation number 2 and legally, it's going to be something called a legal move. I can add equation number 2 to equation number 1 and the equality is going to be preserved. Because remember, right, equation number 2 was this, right? It was -3y plus 5x is equal to 16. And for those of you doing geometry this year, right, that's the addition property of equality. If I have 3y plus 2x equals -2, and that's an equal statement because it was given to me, I can add an equal quantity on one side, right? -3y plus 5x, right? That is equal to 16. So as long as I add 16 to the other side, what it's equal to, my equality is preserved. And the resulting equation is also true in this situation here, okay? So we're taking equation number 1 and we're adding equation number 2 to it. That's how a math teacher might tell you. It's like, just add the equations. What they really mean right there means add the one side of the second equation and another side of the second equation. Add this one to one side of the first equation, right? Here's the sides of the equations here, right? I'm just basically taking that equation number 1 and adding the left side of equation number 2 to the left side here, and the right side of equation number 2 to the right side here, because check it out. This is what happens when we eliminate here. And look here, just see, do you have to answer anything here? Decides to add this? Well, I'll just show you what happens, right? What happens is 3y minus 3y, we're adding 3y to this, or adding -3y here. 3y minus 3y, that's a 0. Right? It ends up equaling 0 there. And check it out here. Remember, I'm just adding an equal quantity over here. So this is 16. I got to add that. Maybe I'll do that right now. Okay, -2 plus 16 is 14. And that's got to be equal to, well, 0 and then plus 7x. Look at that, 7x. So 7x equals 14. And does that look familiar? Yeah, it does, from the substitution problem earlier. Look at that here. So we did all of this garbage, all this work, when we could have just added the freaking equations together to eliminate variables. So 7x equals 14. Man, so much work with substitution. Here, this one's all set up just to add the equations together, right? But really what that means is add one side of the second equation to one side of equation number 1, and add the other side of equation number 2 to the one side of equation number 1, and you just happen to get variables eliminated there. Y eliminates. Now we get x. Okay, so it says write a new equation for the result of Jeanette's addition to both sides of the equation. I did that in part C, so I get 7x equal to 14. Notice how you only have one equation with one variable. Fantastic. And this one's easy to solve here. What happens to the y terms? Okay, they canceled out. Right, they got eliminated. Right, they got eliminated. Okay, simplify and then solve this new equation for the remaining variable. Well, this is very easy. Again, I say start away from the variable. There's only one thing happening to this variable, and that's 7's getting multiplied to x. So to undo multiplication is division, right? Remember, addition and subtraction are opposites. Those are called inverse operations. Multiplication and division are opposites. Those are called inverse operations. They undo one another. Okay, so 7's getting multiplied to x. We divide by 7. 14 divided by 7. If I divide one side by 7, I got to divide the other side by 7. And my equation remains balanced. So I end up with x equals to 2, like I did earlier. Okay, simplify and then solve this new equation. There we go. We got x equals to 2. Use your solution to find x to find y. Well, I can go back to 3y plus 2x is equal to -2, which I did earlier, right? 3y, what was it? 3y plus 2x, and x I have here is 2, so I'm going to plug in 2 right here, and that equals -2. So, right, I already did this. 3y plus 4 equals -2. Subtract 4 from both sides. I get 3y equaling to -6. Y equals -2. So I end up, and it says here, find y. Check your solution to make sure both your original equations are true. So I got this here using the first equation. So check both equations are true. So maybe I need to test this. What they're saying is test this in the other equation here. I got what I got using substitution, so I'm pretty sure this is right. But one thing we haven't done yet, it's trying to say here, is to check in both equations. So we need to check in the other equation, right? That's what that question is asking here. Again, you're pausing the video, you're watching certain sections, trying to keep up with me if you can, but pause the video, fill in your answers, that kind of thing. This is how this distance learning thing can work. So I got -3y is the other equation. So I'm going to try this, -3. Instead of putting y, I'm going to put -2 in, because that's what we think y is. And what's my other equation? It's -3y plus 5x is equal to 16. So we'll do plus 5, and x is 2, and that's equal to 16. Let's check to see if that is a solution to this equation, the second equation. We know it's true here because I solved for it. I got -2, and 3y plus 2x equals -2, so we're just doing the second equation right now. -3 times -2 is 6. 5 times 2 is 10. Does 6 plus 10 equal 16? Yes, it does. Indeed, indeed. Okay, pause the video, take a deep breath. I'm going to keep going. I got to pick my daughter up at daycare pretty soon, so let's check it out. Now use algebra tiles. No, we're not using algebra tiles. We don't need to use algebra tiles. We're not using algebra tiles. It's distance learning. And the equation that to solve the system of equations that right for x and y, check your solution. You should know what to do, right? I'm going to get rid of that equal sign. Okay, get rid of it here, because all I'm going to do is I'm going to add that quantity to this side, and I'm going to add 10 to that side right there. Here, I'm going to block it off here. -2 plus 10 is 8. 2x minus 2x is 0. X eliminates. -y plus that 3y, that's going to bring me up to 2y. Okay, got -1y. I'm adding 3 to that. 3 is a lot bigger than 1. So my result's going to be positive, because 3 is positive, rows 1 is negative. So 3 minus 1 is 2, yeah, something like that. Think through it that way. So 2y equals 8 is the result of eliminating that here, but we got to figure out what y is. Y is going to equal 4, right? Because 2 times 4 equals 8, or divide both sides by 2, and 8 divided by 2 is 4. So we get 4 for y, and now we got to get x, okay? Now we got to get x. So I'm going to go back to one of my original equation here. I'm going to go back and take this guy right here. And I'm going to do 2x minus 4 for y, right? This is one of my answers. I got to get the other answer. That's equal to -2. So I get 2x, add 4 to both sides, and I get positive 2 here. Divide both sides by 2. I get x equal to 1. Okay, so my solution, and I like to write in as coordinates here, just to keep, just to make sure that I did the whole system. So remember, system of equations. 2 or more equations that share the same variables. And usually that's 2 variables. So write it out as a coordinate pair. right? They're paired up with one another. There's my solution on the graph. If I had both those lines graphed, they'd intersect at 1, 4. All right, continuing onward here. Let's see if I can get done with this on time to pick on my daughter before I get charged more here. She's at daycare if you didn't hear me earlier. 4:57, Pat was in a fishing competition at Lake Pisces. He caught some bass and caught some trout. Each bass weighed 3 pounds and each trout weighed 1 pound. Pat caught a total of 30 pounds of fish. He got 5 points in the competition for each bass. But since trout are endangered in Lake Pisces, he lost 1 pound for each trout. Pat scored a total of 42 points. One thing that I haven't emphasized about you here, which I would recommend you underline, you really draw your attention to, is this thing for each. For each. Right? For each. When we see for each, it kind of works like a slope. Kind of works like I have this many for every one, right? For every one. So for each can help you define the variable. So maybe we need to write our let statement. So let's write our let statement right now. So let, and we don't know what's going on. Maybe we get to answer a question later. Solve the system, find out how many bass and trout Pat caught. So that must be our variables, right? We don't know how many bass he caught. We don't know how many trout he caught. It could be 1. It could be 100. It's an unknown. So maybe that's how we're defining our variables here. So he caught some bass, caught some trout. We don't know how many. It's going to be a variable until we know we've solved for the exact solution of this particular situation. So let's do it here. Let's define our variables. Let's let B equal number of bass caught. And let's let T equal the number of trout caught. Maybe I would, in retrospect, use O because T looks like a plus, and that confuses people here. So be careful of that. Number of trout caught. Okay, number of trout caught here. Okay, I got 4 each here. I got 4 each here. He gets 5 points in the competition for each bass, and he loses 1 point for each trout, of which he scored a total of 42 points. Okay, so it looks like we're going to have a total points equation. Okay, we'll get a points equation. So this is a system so that we're looking for 2 or more equations. His point equation is going to be, and it says for each. So this is going to work kind of like a slope. 5 points for each bass. So 5 times however many bass he has. Just think about it in your head, making sure it makes sense. Well, if he has 1 bass, 1 times 5 is 5. That's 5 points. 2 bass, how many points does he get? He gets 10 points because 2 times 5 is 10. 3 bass, that's 15 points. 3 times 5 is 15. I think we set that up correctly. Instead of plus, I'm actually going to do minus. I'm going to do minus 1 because he loses 1 point times by however many trouts he catches. Okay, 5b minus 1t, and that's going to be equal to 42. That's one equation, one relationship of equality that's set up for us here. Total points is 42. And how did he get there? Number of bass multiplied times by 5. He lost 1 point for every trout. We don't know how many he got here. But it says here also, it looks like we're going to have a weight equation. That's the other kind of relationship being talked about. Relationship of equality because it's an equation. So a weight equation is going to be what? Is each bass weighed 3 pounds. So we got each. Each is listed here. Each is listed here. So 3 times by B, 3 pounds for every 1 bass, right? 3 times the number of B. And then each trout cost is 1T, right? Weighed 1 pound, and he caught 30 pounds. So 30 pounds is a fixed number, right? It's not next to a variable. 30 pounds is a constant in this problem here. All right, great system. Yes! The equation is written in standard form, right? This is standard form, right? A number times a variable plus or minus a number times a variable equal to a number, right? Ax plus by equals c, right? That kind of thing here. Equations are both, right? Are both written in standard form. And this whole thing is just set up for us. Whole thing is just set up for us, right? Because look at this here. My variables t's, if I add negative 1t to positive 1t, they're going to cancel out, okay? So in standard form, and the t variable will eliminate if we add the equations, right? And we know this because negative 1t plus positive 1t equals 0, right? So we're going to eliminate that here. Solve the system to find out how many bass and trout Pat caught. Be sure to record your work and check your answer by substituting your solution into the original equations. Maybe I won't do all that because I got to go pick up my daughter here. But I'll go ahead and part C, I'll do a little bit of the work up here, right? So you should know how to do this at this point, I think, here. So, right, I'm gonna get rid of this equals thing because I'm just adding this right side here. 30 equals 3b plus 1t. So I add 30 to one side of the first equation, okay, which is my result is going to be 42 plus 30 is 72. And if I add 30 to this side of the equation and I add 3b plus 1t to the other side of the equation, my equation remains balanced. Because 3b plus 1t, that's going to equal 30 based on the situation of the problem. 3 times the amount of bass plus 1 times the amount of trout is the total weight of all the fish here, okay? So 5b plus 3b is 8b. Oops, I'm going to do that in red. Let's do that in black. And as we mentioned before, these eliminate when we add them together. Negative 1t plus 1t is 0. So 8b equals 72. And maybe I'll do the rest of the work down here. 8b equals 72. After we eliminate, how do I solve that? Start away from b. Oh, wait, there's just an 8 being multiplied to b. How do I get rid of that? Divide both sides by 8. Okay, division, the opposite of multiplication. Okay, those go away. 72 divided by 8 is 9. Okay, so b equals 9. And then let's use my other, or I can use either of these equations here. Let's do this one because this one doesn't have subtraction in it. So let's do 3 times by 9 plus 1t. We got to solve for t, right? You got to get that other equation. You got to figure out how much freaking trout got caught. 3 times 9 is 27 plus 1t equal to 30. Okay, 1t, t's already really isolated. I didn't even need the 1 there. I could have just written t right here. Subtract 27 from both sides, and t equals 3. Okay, I'm not going to check my answer because I've done this a few times. I think that answer is right here. I would write your answer as a sentence, though. Okay, so that Emma has an easier time finding this one here. Okay, Pat caught 9 bass and 3 trout. Okay, ideally you're checking your answers here too. That'd be very nice if you did that. That makes us happy here. Annie needs your help. That's right, she needs your help. Check it out. Annie was going to use the elimination method. She was ready to add the same value to both sides of the equation to eliminate the x terms. When she noticed a problem, both x terms are positive. Oh no, so this you have to remember we did yesterday in class for elimination. With your team, figure out something you can do to allow add the value of the second equation to the first equation, eliminate the x terms. Well, yeah, we can't add these two together right away. This would be 4x, 7y plus 3y, that's 10y. 13 times 5 doesn't matter, it's 18 because we haven't eliminated any variables, okay? So hopefully you figure this one out on your own. If not, I'll explain it here. Well, you know what? We can actually subtract both sides of the equations. We can do that. Or what we can do is we can multiply this by -1, right? Remember, we could find an equivalent equation, okay? So find, right, multiply, right? Remember we did this yesterday. Multiply to find an equivalent equation, right? An equivalent equation, okay? So if we did that here, we'd move this over here, and we would get 2x plus 7y equals 13. We haven't modified that one. Here, as long as I multiply one side by -1, I can have to multiply the other side by -1, and my equation remains balanced, right? Multiplying the same thing to a number that equals another thing is going to result in the same thing if you multiply that other number by the same thing. Anyways, multiplication property of equality for you geometry folks right here. So then this down here is going to become -2x minus 3y equal to -5. Now we can eliminate. Those eliminate. 7y minus 3y is 4y, and that equals 8, and you can solve from there. Y equals 2, and 2x plus 7 times by 2 equals 13. Oh, is this going to be a fraction? It might be a fraction. Unless I did something wrong. I might have done something wrong here. 14 equals 13. Subtract 13 from 14 from each side. I got 2x equaling -1. And I got a fraction for this one here. Divide both sides by 2. I got x equals -1/2. Did you get the same thing as me? Maybe. Maybe. I don't know. Sometimes I make mistakes in these videos. Send me an email if I made a mistake on that one. And we're good to go. All right, getting there. I got to get my daughter. Here. So let's check this one out. Find the point of intersection for each pair of lines below. Show your steps algebraically. Check each solution when you're finished. Let's check it out. These are easy. Yes, easy. I'll get my daughter on time. This is fine here. Eliminate. Here we go. Written in standard form, written in standard form. These are all written in standard form, so we're double checking. The key thing is you want to make sure the equal signs are above one another, right? Because remember, you're adding things that equal each other to each side of the top equation. That's basically what you're doing. So you really just cross this out because you know that they're equal to each other. And let's just see if we can just add them. Add this, and then add that. Add this, and add that. Add this to the left side. Add that to the right side here, okay? I'm going to start over here. I'll start with C. 1 plus 2 is 3. And here, oh, this one doesn't eliminate. This one's a little bit harder. Let's do this a little bit later. So maybe I'll get rid of this out of your way because you just want to do it and get over this, get on with your life here. So you might want to just be checking your answers right now. I got here, if I eliminate, this is going to work out nicely because look at this. I got negative x right over a positive x. So I add 2y to negative 3y. That's negative y. Negative x plus x is 0, and 5 minus 9 is going to bring me down to negative 4. Okay, what happens when I have negative y equal to something here? I can just flip both of the signs, and y would equal 4. Okay, y would equal 4 right there. Doing it in my head, I might just do it in my head real quick here. Y is 4, so this is going to be 8 minus 3. X is going to have to be 3. So that's what I got for this one here. Hopefully you get the same thing too. Okay, I'm allowed to just flip it, so that's actually kind of a time-saving thing. Negative y equals negative 4, then positive y's got to equal 4. And I know that because if I just divide both sides by negative 1, right, negative 1y divided by negative 1 cancels the negative. Negative 4 divided by negative 1 is positive 4 here, okay? 2 more left, and then we'll be good to go. 14 minus 11, so this one, we'll see this one eliminates. Yes, this one will eliminate here because this is where you got to be careful. I got my y's. They're not stacked on top of each other. But yeah, like we could rearrange that. You're allowed to rearrange your variables if they're separated by pluses or minuses here. So instead of writing this, what I can add to the left side of this here would be negative x, adding negative x plus 4y. And that's good. That'll help us eliminate. And I'm going to add negative 3 or just subtract negative 3 from this side here, okay? So right, you can rearrange those are called rearranging your terms, right? Addition and subtraction, or addition, it doesn't matter what order you're doing. So think about this as adding a negative x. So let's move that negative x to the front. And we'll add the positive 4y afterwards here. Anyways, now I got it on top of one another. Sometimes you just like things certain ways. I like having my x's right on top of one another from eliminating, or my y's on top of one another. So here we got 2x minus x, and that's going to be just x, and negative 4y plus 4y, that brings me to 0. Those ones eliminate. Okay, and that's x equal to 11, right? I got 11. What's my y? X is 11. You got to show your work. You definitely have to show your work here. Show your steps, okay? So if Emma sees this or I see this, like, where's your work, bro? Bro, what is this here? We're not friends. I'm your teacher. Anyways, now we got to get y for this. I digress. What's easiest for you get y? I'm going to get this one. So 4y minus 11 equals negative 3. Add 11 to both sides. That would bring me to 8 here. Divide by 4, y equals 2. That's what I got. Did you get it, though? Be honest with yourself here. This is the harder one, my friends. That's right. This is the harder one. I just said we're not friends. What is this here? Multiply both sides by negative 1. Okay, I'm going to do that because, again, I'm finding an equivalent equation that I can use to eliminate here. Okay, so I'll cross that out so we can ignore this. Negative 1, and then that becomes negative 2x. Negative 1 times by positive 4 is negative 4y. Sorry, positive 4y is negative 4y. And then 2 times by negative 1 is negative 2. We'll get rid of the equal signs. We're just going to eliminate here. 1 minus 2 is negative 1. 2x minus 2x is just x. And then the 4y and negative 4y eliminate. X equals negative 1. Negative 3. Add to both sides is 4. So y equals 1 in this one. And hopefully you solve there. Hopefully you get what I got. And that's my answers. I would write your answers as coordinates, right? So that we can see them. Because they're pairs. They're coordinate pairs. This is where the two friggin' lines intersect. They go over one another here. 11, 2, and that is that. Hopefully you guys watched this. Hopefully you guys got it. Hopefully you weren't overwhelmed by all the writing in here. Hopefully we cut through all that stuff by watching this video. Thank you for watching. Hopefully you have a wonderful Thursday. I will see you on Friday. More system stuff. I like systems. Systems are great. Bye.